Lab Communication Systems, Lab. Experiment number 4. Amplitude Demodulation. Experiment No. 4. Amplitude Demodulation. Objectives. To understand the theory of amplitude demodulation, to design and implement the product detection amplitude demodulator. Equipment required: oscilloscope, DMM, function generator, dual channel, DC power supply, plus 12 volts fixed, plus 5 volts fixed, minus 5 volts fixed. Balanced modulator MC1496 QTY equals 1. Resistors 1K omega QTY equals 4, 2 kilo ohms QTY equals 3, 10K omega QTY equals 1, 270 ohms QTY equals 1, VR 100K omega QTY equals 2. Capacitors 0.1-UF QTY equals 6, 2.2-UF QTY equals 2, 10 NF QTY equals 2. Connecting wires. Breadboard. Theory. Amplitude demodulation. In amplitude modulation, amplitude of audio signal is utilized to modulate high-frequency carrier signal. Therefore, when we receive the amplitude-modulated signal, we need to restore the original message audio signal. Figure 4:1 is the illustration of amplitude demodulation. Figure 4.1 Amplitude demodulation theoretical process. To demodulate the signal received at receiving end, a detector circuit is designed and utilized. The detector can be classified into two categories: A. Asynchronous detector. B. Synchronous detector. Asynchronous detector. Diode detector. Since amplitude modulation signal utilizes the audio signal to modulate carrier signal, which means the variation of carrier signal amplitude is followed by the change of audio signal amplitude, hence the objective of amplitude demodulator is to take out the variation envelope detection from amplitude modulation signal. Figure 4.2 AM demodulation block diagram. Figure 4:2 is the block diagram of the rectification demodulator circuit. Is typical asynchronous detector. It rectifies the AM signal and obtains a positive half-wave signal. After that, the signal will pass through low-pass filter and obtain an envelope detection. After it, DC component is removed, leaving behind the original signal. Figure 4.3 Diode detector circuit. Figure 4:3 is the circuit diagram of diode detector, in which R1, R2, R3, R4, U1 and U2 form two groups of inverting amplifiers to amplify the input signal. D1 is the rectifier diode, which the AM signal, a positive half-wave signal. C2, C3 and R5 comprise a low-pass filter to remove the envelope detection signal of the audio signal, which includes the DEC level. Then finally, the objective of C4 capacitor store move the DC component and pure audio wave is obtained at output. Synchronous detector, product detector. The amplitude demodulation can be implemented by utilizing a balanced modulator. The circuit is synchronous and is called product detector. Figure 4:4 is the internal circuitry of the MC1496 balanced modulator, the same which has been used for amplitude modulation and is explained in last lab. Figure 4.4. Internal circuit of MC1496. Let XAM-T be the amplitude modulation signal and XC-T be the carrier signal. When the two signals input and out were differential ports of balanced modulator, the output of the balanced modulator is follow, where K represents the gain of the balanced modulator. The first term is the DC signal. Second is the audio signal and third term is the second harmonic of amplitude modulated signal. If we can take out the second term and X out T, then we can obtain the exact amplitude demodulated signal or message signal. Figure 4.5 Product Detector. Figure 4 to 5 IIS. The circuit diagram of product detector. VR1 controls the input magnitude of carrier signal. VR2 controls the input magnitude of amplitude modulated signal. The output signal is located at pin 12 OFM C1496. C7, C9 and R9 comprise a low-pass filter which can remove the unwanted third term of the equation 4 to 3, the DC signal.